Hi guys, we're on Unit 4, and this is day 2. We're going to be identifying transformations, which we spent a little bit of time on day 1, but these ones are all going to be on a graph. So here we go. So here's a warm-up, and it says, given AD bisects angle BAC. So I'm going to find angle BAC, B to A to C. So that angle is being cut in half since they use the word bisects. And so it's going to give me two equal angles in there. Here's one of them, and here's the other one. Okay. Then it goes and tells me that AD bisects BE. So if I find BE, that is being cut in half, and that's a segment being cut in half. So segments get tick marks, whereas the angle gets arc marks. Okay. All right. So part A is done. Name a pair of vertical angles. Remember, vertical angles happen when you have that X shape or two lines crossing, one angle on one side, one angle on the other, or they could be on the top and the bottom. And I see that X shape right here in the middle. And so I'm going to go ahead and name this angle here and this angle here as my vertical angle pair. So I'm going to tell you that that is angle BFD, angle BFD, and the one down here with the star, AFE, angle AFE. Okay. Part C says name two congruent angles that are not vertical. So those are the ones that we arc marked. Okay. And so this top one with the arc mark in it is called angle BAF. And the bottom one with the arc mark is angle EAF. Okay. Part D, name two angles that form a linear pair. All right. So there are 4 linear pairs in the middle. Okay. There's one linear pair over by point D, and then there's one on the bottom here by point E. I'm going to go ahead with the point E one. I'm going to use green to show you guys there's my line. There's my separator. There's one angle on one side, one angle on the other side. All right. So angle 1, I'm going to call angle AEF. And the angle 2 on the other side, I'm going to call it angle CEF. Okay, part D done. Name two congruent segments. Those are the ones with my tick marks on them. So BF has a tick mark on it, and so does FE. All right, warm up is done. So on to number 1, it says graph each figure and its image, then identify the transformation and the mapping rule. We haven't talked a whole lot about mapping rules, but we're going to. Yeah, show you guys what they are. So first off, I got to graph my triangle. So it's triangle HJK. H is at -3, -1. When you graph, make sure that you label each point, okay, with the letter. J is at -3, 1, 2, 3, +4. Okay, and K is at 0, 0. That's easy. All right, I'm going to go ahead and connect them. I really hope that you guys are using straight edges. Okay, that would be really helpful. Ooh, if I can figure out how to use my straight edge, that'd be great. Not quite sure I do, though. Yeah, it's all a learning experience, right? Let me see if I can do this again. Yep. So I have to go back to it each time, which is kind of annoying. I had to open my toolbar and then pick the line segment. There we go. But it's worth it. That looks like a nice triangle, okay? And so then they tell me that after a transformation, the image of the figure now has vertices at H prime, J prime, and K prime. So I'm going to go ahead and graph that one. I'll graph that one in red. So +1, -3, and that's called H prime. J is at +1, +2, J prime. And +4, -2 is K prime. Okay. We'll go ahead and connect them with some straight lines. All right. So now we have to figure out what transformation if those are our two triangles. And hopefully you guys can see that this is not a flip. It's not a turn, that the blue triangle slid and ended up on top of that red triangle. And so this is a translation. Okay. In a translation, we try to be as specific as we can. So we're going to go ahead and tell us our movement. It's always left or right movement first. So this one would be 1, 2, 3, 4 units. Okay. So we would say 4 units, or we could just say 4 right. And then the second movement we talk about is either up or down, and this would have had to gone down 2 units so that H ends up on H prime. So we'll say 2 down. Okay, we're going to talk about how to notate that, which is a lot easier than writing it all out like we just did. Use a capital T. 4 to the right. Right is a positive direction, so you just write down 4, comma. 2 down would be a -2 because down is a negative direction. Okay, so is to the left. And that is what our notation would look like. That 4, comma, -2 is what they call a subscript. It's below the line of writing. Okay. And you guys can see that if you decided to do J to J prime, it's also 4 to the right, 2 down. Or K to K prime, also 4 to the right and 2 down. Okay, so translations always work like that. So the next thing we're going to talk about is the mapping rule. Okay, a mapping rule tells you what to map the coordinates on. So all coordinates start off as x comma y. And then we draw a little arrow to show what they're mapping onto. And what we're going to do to the x coordinate is we're going to go 4 right, which is the same thing as adding 4. But you're adding 4 to the current x coordinate. So it'd be comes x plus 4. And then whatever the y coordinate is, so we'll just call it y, goes 2 down, which would be a -2. And that's a mapping rule. Okay. And so we identified the transformation not only in words, we also identified the transformation in notation, and then we also talked about the mapping rule. All right, so here we go on number 2. Oh, no. I don't know why this happens. All right, we'll just move each piece. I don't know why they don't move together. So confusing. I'm trying to get these out of here. All right, let's see if I can erase them maybe. They're kind of in my way. Technology. No, I can't erase them either. Interesting. All right. Well, I guess we'll just do number 2 down here. And hopefully the same thing doesn't happen. So, all right, so here we go. We have triangle CDE and has vertices at C, who's at -4. 1, 2, 3, 4. +6. 1, 2, 3, 4, 5, 6. And D is at -1, +6. And then E is at -2, +1. Okay, we'll use our straight lines to go ahead and connect them. Okay, and then it's going to tell me where our new triangle is. So it says after transformation, the image of the figure has vertices at C prime, which is at +4. 1, 2, 3, 4, +6. That's C prime. D prime is at +1, +6. And E prime is at +2, +1. We'll go ahead and connect with our straight lines. I'm going to try something different. I wonder what happens if I use this tool. Not that I want to. Oh, no, I get a star. Well, we can give ourselves a star. All right. Let's try the straight line thing again. Okay. All right, so there's our triangles. And now we are going to go ahead and figure out what the transformation is. So it seems like, is this a turn, a flip, or a slide? I don't think it's a turn. I don't think it's a slide if you look at the letters and you see how C and D don't slide over. Okay, but I do think that this triangle is flipping. And I think that this triangle is flipping right over this line. See how D to the line is 1 unit, and then D primed from the line is 1 unit. And this is a reflection. So we're going to go ahead and say reflection. When it's a reflection, we have to tell over what line. So we're going to say over, and that line is known as the y-axis. Okay. When we notate, they use a lowercase r for reflections, and they use the y-axis, the line you flipped over, as the subscript. Okay. And then we have a mapping rule. And in our mapping rule, we always start off with x comma y, and then we go and say what happens to x and y. And this one's a little bit tricky. Okay, there's nothing to add or subtract like in the translation there was. But if you take a look at the coordinates, I think you can figure out what is happening. Every single time, whatever the x coordinate is becomes the opposite sign. So it was negative, then it becomes positive. This was negative, it becomes positive. This was negative, and it becomes positive. And so the x coordinate is the one that's changing. And so to change it, we're going to put a negative in front of our x, comma. If you look at the y's, all the y's are exactly the same. 6 and 6, 6 and 6, 1 and 1. So nothing's happening to the y, so we don't do anything to the y. And there's our mapping rule. Okay. All right, let's try moving this again, and we'll do number 3. Nope, nothing wants to move along with it. No, some of it does. Not the what I graphed on the grid. All right, so we're going to go ahead and just move this over so we don't have to start a new video. Okay, and then we'll go ahead and start a new video for the next page. Where the same thing's probably going to happen, but we'll give it a shot. Okay, so in number 3, it says a figure has vertices at D, which is at negative 2, 1. Oops, I want to do blue. Okay. And E is at negative 3, positive 3. And F is at 0. Be very careful with 0, especially when the 0 is here. I often graph them wrong as well, so I know that you guys do as too. So 0 means no left and right, and then 3 means up 3. And then we're going to go ahead and use our straight edge and connect them. Okay, and then we're going to go ahead and look at our image. So D prime is at negative 1, negative 2. E prime is at negative 3, negative 3. And then F prime is at negative 3, 0. Okay. We'll use our straight edge to connect them. And let's see what happened to our triangle. Did he flip? Doesn't look like it. Did he slide? No. It does look like he turned though. Okay, so this is a rotation. In this class, we are always going to rotate around the origin. The origin is like our pivot point. When you rotate around a point, okay? And so those triangles are staying the same distance away from the origin. They're rotating around the origin as they turn, okay? All right, so next thing we have to figure out is how many degrees we rotated. Okay? Rotations are going to go the same way the quadrants go, which is counterclockwise. And so I think if we take this blue triangle and just turn in 190-degree rotation, it's going to fall on that red one. So we're going to say that it's a rotation around the origin of 90 degrees. If we wanted to notate that, we would use a capital R because lowercase r is for reflection, O for the origin that we rotated around, and then 90 degrees. Okay. And then for our mapping rule, okay, we're going to start off with x comma y. And we're going to go ahead and see where they map onto. Now this one's a little bit tricky, okay? But if you take a look at those coordinates, maybe you can figure it out. I would not look at E's coordinates because they're both 3's, okay? And I don't know if I would look at F's coordinates because of the 0. Okay? So you're going to have to look at the D to D prime and see if you can figure it out. But if you notice, there's a 1 and a 2 in the image, but in the original, there's a 2 and a 1. All right, so hopefully you guys can see that they're swapping positions. So I'm going to go ahead and swap my positions. So I'm going to put the Y first and the X second. Okay? If I swap these two, this would be a 1 first and then a -2. And then you're going to see that that doesn't quite match that yet. Okay, so what they're doing is they're putting a negative after they're swapped. So we're going to put a negative on the first one after they're swapped. And there's our rule for a rotation of 90. That one we never should memorize because a rotation for 90 has a different rule than a rotation for 180, who has a different rule for a rotation of 270. All right, I will see you guys on the back side of notes for the second part.